Alright, in this video we're going to go over a released test question that has to do with the triangle proportionality theorem. So before we get into the question, let's review what the theorem says. So the triangle proportionality theorem says, if a line is parallel to one side of a triangle and intersects the other two sides, so all of that is our hypothesis, then it divides the sides into segments of proportional lengths. That would be our conclusion. So we're saying if we have a triangle where a line is parallel to one side of the triangle and intersects or crosses the other two sides, then that line divides the sides into segments of proportional length. So the question that we're going to look at here says a triangle JLM and line segment KN are given. So here, that is given in the picture. We have triangle JLM with line segment KN. A proof of the proportion JK, which is our blue segment, over JL, which is our green segment, equals JN, the pink segment, over JM, the orange segment, is shown. Which statement must be added to the given to keep this proof valid? So here, if you look at our proportion, remember a proportion takes two ratios and it sets them equal to each other. So the ratio on the left-hand side here, JK to JL, both of those pieces are on one side of the triangle. Our ratio on the right-hand side of the proportion, JN to JM, JN and JM are both on the same side of the triangle. So when we're using a proportion to compare two pieces on the same side of a triangle, we know that we're using the triangle proportionality theorem. And looking at our theorem that we have on screen here, one very important thing that we have to have in order for the triangle proportionality theorem to work is a line that is parallel to one side of the triangle. So if we look at our choices here, that's what we need to add to our given. We have to have a segment that is parallel to one side of the triangle before we can say anything relating to the triangle proportionality theorem. So if you look in the picture, KN intersects two sides of the triangle and it has potential to be parallel to LM. So for our proof to work, we have to say that segment KN is parallel to segment LM. So right away, we know we're talking about KN and LM. So we can cross out any of our choices that don't involve those two segments. So A is out and C is out. Now, if you look at B, here's where knowing your notation is really important. B says segment KN is perpendicular to segment LM. Remember the symbol that looks like the upside down T means perpendicular. So now we can say B is not a logical choice because the problem doesn't have anything to do with perpendicular segments. In order to use the triangle proportionality theorem, we need two parallel segments, which is exactly what letter D is saying. So letter D says segment KN, which is highlighted here in yellow, is parallel, remember the two lines next to each other, that's the symbol for parallel, to segment LM. So letter D here is the correct answer. That statement, segment KN is parallel to segment LM, has to be added to the proof as a given in order to keep the proof valid.